So we're going to calculate the arc length of this function as indicated right here. And we're going to do this without a calculator. So it's going to look complicated, but when they say without a calculator, that means there must be some way you can handle it. And that's what we're here to check out. So first of all, the arc length, we have to take the integral from, in this case, 2 to 3 of the square root of 1 plus f prime of x quantity squared. So let's first figure out what f prime of x quantity squared is. So this derivative would be 4 times 1/8 is 1/2 x to the negative 3, or I'm sorry, x to the positive 3. And this is 1/4 x to the negative 2, so minus 1/2 x to the negative 3. And now we're going to square that. So I'm going to use square double square here. So y equals, let's see, that 1/2 we can factor out, so we don't have to worry about it. And the square double square part of it is x to the 6th, and then minus 2x to the 3rd times x to the negative 3, which is 1, so minus 2. And then that's square double, and then square the last term, which remember we took the negative 1/2 out, so it's x to the negative 3 squared, which is x to the negative 6. Oops. I just squared it. The only thing I didn't square was the 1/2. Because I factored it out, that's going to become 1/4. Okay, so I squared, I confused myself there. I did this. And then I had to square the whole thing. So the square double square was right here. That was pretty simple. And then I had to square the 1/2 too. So this is going to be 1/4 times this. So that's y prime squared. Bad notation on my part, but I did take the derivative and then I did square it. So I have to add 1 to that because now I'm going to go over to this integral. So I'm going to integrate 1 plus 1/4 times x to the 6th minus 2 plus x to the negative 6. Trying to figure out how I'm going to do this. The whole thing here is that 1 is like completely in the way. Let's combine everything. So we're going to have to multiply the 1/4 through. So this middle term is going to be minus 1/2. The reason I did that is because I need to add this 1 in with it. So I'm going to have 1/4 x to the 6th minus 1/2 plus 1, which is plus 1/2, and then plus 1/4 x to the negative 6. So now I have to figure out a way to differentiate that. Well, I think the best thing to do here is to refactor the 1/4. And if you do factor out the whole 1/4, since the square root of 1/4 is 1/2, we can do this. So I'm factoring out 1/4. I'll have x to the 6th. If you factor out 1/4 from 1/2, you'll have to multiply the 1/2 by 4, which is 2. And then, now that looks kind of familiar because look at this. This came from square double square. So that means this is a result of square double square, so it factors as a perfect square trinomial. In other words, it will go back to this thing. So from algebra 2, if you don't want to think backwards here, as long as this is a perfect square, and this is a perfect square, and this is twice their product, this is a perfect square trinomial. So the square root of x to the 6 is x to the third. The square root of x to the negative 6 is x to the negative third. If you multiply those together and double them, you'll get 1 times 2, which is 2, which is the middle term, meaning that was a perfect square trinomial, meaning it factors like x cubed plus x to the negative third quantity squared. Now that helps us a lot because we're taking the square root